All right, everybody. So here we are, session 4. Welcome to you all. Um, Last week we were talking about ratios. We took pencils in our hands and we were tapping ratios, and it was a very interesting experiment. So if you'll remember, we were doing this, and if you watched the video, you said, okay, if I'm tapping two at the exact same time, that's what we call a 1-to-1 ratio, which means if this note is C, then this note is C. Yes, we're just tapping. Yes, it's just rhythm. But what happens when we speed that up? When we start speeding it up and it goes so fast that you can do it maybe 100 times per second, you start to hear pitch. I've been teaching this concept for years. And I would always tell my students, okay, if you could speed that up, if you could record it and play it back faster, well, I never had the means to do that, or at least I never looked into getting the means to do that. Art has created a video for us, a short video that shows us exactly how that works on an electronic keyboard. And I'm so thrilled that he did this because when I watched it, I was like, holy cow, this makes all of the concepts real to the students. And so we'll show you that in a moment. So let's talk about this. So we decided that if you could tap 1-to-1 and both of these, if one of them was a C, the other one was a C. Then we said if you doubled one of them and you got a 2-to-1 ratio, that this one would be a C, but this one would be the next octave up. It would be a doubling of the original. So every time you double a note, you get, or double a frequency, you get the next octave up. So I could make the next octave up by doing 4 in this hand and 1 in this hand. And if you could speed that up, you would hear one C or one fundamental note and then 2 octaves higher. And 8-to-1 and 16-to-1 and 32-to-1, etc. An octave is a doubling. An octave is represented by the number 2. Okay. Then we moved on and we said, okay, what about a 3-to-1 ratio? When you get, we said that that was going to represent the perfect fifth because the ratio of the overtones of the third partial is 3-to-1. I'm sorry, of the third partial is 3-to-1, right? And that gives you the perfect fifth. So if you could speed up this, you would hear a fifth. Actually, you would hear an octave plus a fifth because that's where it lies in the overtone series. Then if you went up to a 4-to-1, that's the octave. But if you went to 5-to-1, if you did 5 notes against one, that's the ratio of the E, but it's 2 octaves and a third higher. This might sound very odd to talk about and very abstract. So if it sounds very abstract to you, what I would say is go to last week's lesson. Sorry, I'm trying to get to, continue. Okay, sorry. I don't know what's happening here. Hold on. Okay, if it's sounding too abstract to you, then I would say go back and watch that video because it's all made a lot more real by looking at those things. And I don't want to just rehash what we did in the last video. Now, you'll have to just trust me until you go experience it yourself, that these notes are based on the overtone series and the distance they are from the original note is based on the overtone series. So let me share my screen and let's look at the overtone series real quick. Just go find a picture of one, and here's the first one. This is going to be fine. Okay, so let's look at this. No, that's not what I want. There we go. Okay, so if we're looking at the overtone series as you see it here, the first fundamental note, let's say we're in the overtone series of C. We'll relate everything to C. The next one is a 2-to-1 ratio with that C, and that is an octave. The 3-to-1 ratio is the G. It's the third partial. That 3-to-1 ratio is fine, but the notes are getting too far apart for us to put them in like a scale order and to be able to work with them and hear them more clearly. So we're going to have to get rid of the extra octave. I'll show you that. We'll review that in a moment. Then the next one is a 4-to-1 ratio, which is the next C up. And the next is a 5-to-1 ratio, which is the E. Now this is 2 octaves and a major third away. That's too far. We want to get these within an octave. So we have to make sure that our ratios stay within the numbers 1 and 2. 3 divided by 1 is 3. Therefore, that number is too big, or 3-to-1 ratio. That's too big, so we have to get them smaller. How do we get rid of this octave? We octave reduce. We get rid of octaves by doubling the number in the ratio that represents the octave or the fundamental note. Okay, I hope I know this is weird and confusing. Okay. So we came to the conclusion that the 3-to-1 ratio, if we take a 3-to-1 ratio and we want it to make it a number between 2 and 1, to put it in the same octave, we would have to move up the bottom note to get closer to that fifth. And the 3-to-1 became a 3-to-2 because we doubled 1 and made it 2. So here's the hemiola. 1, 2, 3, 1, 2, 3, or 1, 2, 1, 2, 1, 2, 1, 2, or 1, 2, 3, 1, 2, 3, 1, 2, 3. When you hear that rhythm, you are actually hearing the ratio or the rhythm of the pitch of a perfect fifth. You're hearing a C and a G, or a D and an A, or an E and a B, wherever you stop the frequency. And Art described it as rhythm is actually pitch, just slowed way down. And it's true. And again, I've been teaching this forever, and with Art's video, I was able to, we're able to demonstrate how it works. So you'll see that in a moment. The other thing is that if we get to the fifth partial, which is 2 octaves and a third away, we got to get rid of 2 octaves. So how do I do that? I double the octave 1 to make it a 2, then I double it again to make it a 4. The ratio between the C and the E right next to each other is called 5-to-4. And a 5-to-4 ratio is harder to tap, but not impossible. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can't even count the 4. 1, 2, 3, 4. It's harder to count the 4 for me when it's going against the 5. But that cross rhythm of a 4 against a 5 is what our eardrum is actually doing when you're hearing a major third. When you hear the major third, you're hearing those strings in the ratio of 1 string for every 4 vibrations. You're hearing 5 vibrations of the other one. And that's what makes pitch if you speed it up fast enough. Your eardrum will do exactly what the string is doing. The string is vibrating in these ratios. Our eardrum vibrates in those ratios. And somewhere between the ear and the inner ear and the brain, it becomes pitch, and we recognize it as pitch. It's a fascinating thing. I'm not sure that anyone even understands how it works. I don't think we do. It's a mystery how that can happen, because our eardrum is like vibrating in all these different ways. There's a story in the book that says, picture yourself a little tiny person, and you're on the trampoline of your eardrum, and you're bouncing around in all these rhythms, because these rhythms that are coming in are making that eardrum dance that way. It's really quite astounding when you think about it. Okay, let's watch this video that Art has made for us. Let me share screen again. And let me find it. If you want to learn how to do those rhythms, the 3-2 and the 5-4, you can do so by looking them up in the book. They tell you in those chapters exactly how to feel that rhythm. It's not that difficult. Just takes a little practice. It's not necessary because your eardrum can do it anyway. Sorry, I told you I'm working on hobbled equipment. My keyboard is not working. So I have, but my trackpad is. So I have to use a secondary keyboard on top of the old keyboard to type, but then I can't use my mouse because I'm using my USB port for the keyboard. So anyway, that's nothing for you to worry about. All right, if nothing I said made sense, hopefully this video will make sense. Will help you to understand it. And of course, it doesn't want to open. Isn't that nice?
Probably right click on it and then.
I put preview, it doesn't open. I double click it, it's not opening. Well, this just shoots to hell my lesson. All right, we'll try it again later. I recommend you go and you watch this video. If I think it was done on your iPhone. Art, what was that done on?
Yes, on my iPhone. If you want, I could share my. I still have it in my video, and if you make me administrator or something, I could share that.
Yeah, why don't we do that when you get here?
Okay, cool.
Okay, I don't want you to crash while we're trying to do that. All right, Art will show us that video when he gets here in a few minutes. But let's go back to the lattice. So now, assuming that all of that is true, and assuming that you've experienced that for yourself, and you know how that feels, and you know what these ratios are all about, and you understand that when we're tapping, we're actually creating pitch in a very slowed down way. It's like watching a movie which goes something like 24 frames per second. Once it starts going at 24 frames, you start to recognize it as movement, right? Instead of just still pictures. Same thing with the eardrum, but it takes a lot more to get to where we're actually hearing the pitch. So pitch is nothing more than these ratios slowed down. And the ratios are actually the better way of describing exact pitch. If you want to describe exact pitch, the ratios are the way to go. And so then we said, okay, we can hear this, but according to the general terminology page, it's not just hearing the individual intervals or the basic intervals, it's hearing compounds of those intervals to where our ear can compound things. It can hear a fifth of a fifth. It can hear a fifth of a fifth and the third above that. And it can hear them also upside down in what we called reciprocal. And so we started to build a lattice, and we went through the whole lattice building process to get all the notes that are closest to C. Because here's the main point, I think. The ear likes the simpler ratios. The simpler the ratio, the easier it is for your ear to tune. And so if the ratios get too complex, your ear doesn't tune that way. It tunes to other things. It tunes to the simpler things. It tunes to perfect fifths and major thirds. And all the notes can be related to each other by perfect fifths and major thirds. The low prime numbers of the overtone series, either 2 or 3 or 5. There's other overtones. We can go to the 7th partial, we can go to the 9th partial, but these are less, they get farther and farther away from the home tone. And our ear likes to tune to the low primes. That's the whole point. But there starts to become some ambiguity when you start to realize that there are more than one way, more than one path, more than one ratio to different pitches. C and G are always the same. C and G don't change. They're the drone. They're the solid, perfect fifth. You know, it's the lowest note in the overtone series that is different, which is G. But those notes don't change. But all the other notes around them can change their tuning. They can change to different shades of pitch. And that's important when you're teaching your choirs, or when you're teaching your string orchestra, or when you're teaching non-pitched instruments, or variable pitch instruments, voices, violins, sitars, fretless basses, etc. What note do you tune to when you have those options? Okay, so let's look at the lattice. We're going to rebuild the lattice. Here we go. I would take out a sheet of paper and write this down, and then write it down many times. All right, we're going to start, we're going to keep it in the key of C. And C is the center of our C universe.
You might want to stop sharing your screen, Dave, so we can see the white.
Thank you. Okay. Got it. Okay. So perfect fifth from C to G. The ratio of G is 3 to 1. But that's too far apart, we said in the overtone series, for it to be practical to use. So what do? We have to octave reduce. We have to take this 1, which represents C, this 3 represents G, but this 1, we need to double it so we can get the two notes closer together. So we double 1, it becomes 2. 3 to 2 is now a number that is between 1 and 2, because it would be 1.5. That's our goal. If we can get them between 1 and 2, then we're within an octave as far as notes go. So the ratio of a G is a perfect 3 to 2 ratio. And that's more clear than saying it's a letter G. The other note we have, we'll put on top here. This is creating a map for what we hear. This is creating a map so that we can kind of see where we're at harmonically in any given piece of music. The ratio of E is 5 to 4. We start at 5 to 1. For every 5 vibrations of this string, we got 1 vibration of this string, and we get the relationship C to E. But these are too far apart, so we want to get them to be a number between 1 and 2. How do we do it? We double the C. The C becomes a 2. Then the 2 becomes a 4. And we just keep doubling, because every time you double, you get the next octave up. Now we've got the ratio for an E. It's a 5 to 4 ratio. You'll see this on the video when Art gets here. That's all well and good, but other notes get farther away from C, and the ability of our ear to compound these ratios is as part of the amazing thing. Okay, so let's keep going. What is a perfect fifth above G? Answer is D. Now, if this was turning this into a 3-to-1 ratio, that was multiplying by 3. And we ended up with a 3-to-1. Then we octave reduced to get it to a 3-to-2. Every time you go over a Pythagorean move or a fifth, we multiply by 3. So over here, I'll make my little compass. And what we're going to do is every time we go to the right, we're going to multiply by 3. So this is 3 times 3, which makes this 9-to-1. For every 1 vibration of this, there are 9 vibrations of that to get the D. Okay, but we're going to double this 1 to get it closer to the 9. We double it, we turn it into a 2, we turn it into a 4, we turn it into an 8. And now we're at 9 to 8 vibrations. That's the ratio of a C right next to a D, a major second away. Okay, this D is 9-8. For every 8 vibrations of this, you got 9 vibrations for that. Now, I don't know about you, but I can't tap 9 to 8. My eardrum can tap 9 to 8. It can vibrate 9 to 8. That's pretty tricky rhythm to get it like perfect and accurate. There's another brilliant thing about Art's video. He shows how difficult it is to actually press down the 2 notes at exactly the same time. Because as he does them, they keep coming out to different ratios, to different rhythms until he gets it like right precisely on, and then you start to hear that interval happen. It's pretty amazing. The keyboard does it for us automatically, but when he's slowing down the vibrations and trying to really hit that perfect fifth, it's strangely elusive. Okay, so every time we go that way, we multiply by the numerator by 3. Okay, let's go one more. A perfect fifth above D is A. Somebody who was not here last week, tell me what you think the ratio would be. It's open. The ratio is for the letter A. It was open. On the left, on the right. And if you're totally confused, that's okay. What's up, buddy? Bring your chair down.
Does it start with 27?
Yes, it sure does. A 27-to-1 ratio is very far apart in the overtone series, so we've got to get that bottom note closer, right? How do we do it? We start with 1, then we double it to 2, and we double it to 4, then we double it to 8. We can't go over 27. Then we double it to 16. If we go to the next doubling, which is 32, we've gone too far. So we're just going to call it 27 to 16. The ratio of the major sixth is 27 to 16 for that A. It's not the A on the piano. Doesn't sound the same. But overtonally, we have this compounding of all of these fifths on this Pythagorean spine. We said the fifths are going to be called Pythagorean, and up and down are going to be called pentamerous because they're fifth partials. Notice how complex the ratios get really fast. As they get more and more complex, your ear stops listening for those ratios. Your ear starts going for the simpler ones, the ones that are closer to C. And so if you said, I want to hear a ratio that's way out somewhere in the boondocks, you have to find your way to it. But your ear is not going to relate it to that original C. You're going to have to modulate if you want to get to one of those other notes. Okay. That's the Pythagorean dimension. We've now gone all the way about as far as we want to go. So let's figure out where the other notes are. All right, what is a major third above G? And the answer is B. Now, to go up, we multiply by 5 on the lattice. So this can be multiplied by 5. We've got a fifth from E to B. So what do we have to do? We have to start from C and we have to work our way compounding these ratios to get up to the B. What do we do first? We multiply by 3. 1 times 3 is 3. And then we go up times 5. So this becomes 15 for the numerator. And the denominator is going to start at 1. And then we double it until we get close to 15 without going over. And we go 1 becomes 2, becomes 4, becomes 8. If I go to 16, I've gone too far. So the ratio of the major seventh is 15 to 8. Now I'm combining fifths and thirds together. And somehow our ear does that. I've got almost all the notes of the C major scale now. I got C, D, E, no, F, G, A, B. The question is, where does F appear on this lattice? Where does F appear?
It appears before C.
It appears before C, but these are the overtonal dimension, right? F never appears in the overtone series. Somehow all of the cultures of the world seem to find that F in their music making and their scales, but F is not there. F doesn't even exist based off of a single overtone series off of a single note. So where does it come from? Well, it's kind of heard as an upside down. It's heard as a perfect fifth below C. And I like to say that if that's the creator of the C universe, then that would be the Virgin Mother. Somehow this is creating this, right? But this is the actual sounding note, which is creating everything else. So we call this side reciprocal. It's an upside down listening and it's an upside down tuning. A lot of books and a lot of teachers will tell you that the perfect fifth is called the dominant and the perfect fourth is called the subdominant. And you ask them, why is it called the subdominant? They'll say, because it's the scale degree that's underneath the dominant. But that's not true. It's the perfect fifth or the dominant underneath the tonic. That's why it's called the subdominant, right? But the books don't always get this correct. We have to hear it as such. And because it is an upside down listening and an upside down tuning, this is one of the hardest notes to sing in tune in the C major scale. A lot of people will tell you it's E. A lot of professors will say it's E because they want you to sing the equal tempered E instead of the just E. We talked about that last week. But it's actually F. F is the confusing one because it's not in the overtone series. It's not very natural. It's different. So before we figure out this ratio, let's go and find out what note we actually do have in the overtone series way up high. What's a major third above D? It's F sharp. Now, calculate the ratio of the F sharp by using times 3 and times 5, starting at C. 3 times 3 is 9, times 5 is 45. Octave reduced from 1 to 2 to 4 to 8 to 16 to 32. I can't tap 45 to 32, but my eardrum can beat at that speed. It can beat that ratio and it can hear that harmony. It's a miracle. So we have an F sharp in the overtonal dimension, but we don't have an F natural in the overtonal dimension. So we have to hear it upside down or reciprocally. So when we move in the reciprocal dimension, we're going to be dividing instead of multiplying. We're going to divide by 3. Or if you remember back to your math, it's like multiplying 1 over 3. You turn it upside down. I don't know why that is. I'm not a mathematician. I was explaining this to a student online the other day. I said, probably a math teacher could explain some of these concepts better than I can. I'm not a mathematician. Okay, so going from C now, when we go this direction, we're going to be multiplying by 1/3, which is like dividing. Harmony, remember, is multiplicative. So we're multiplying C to F. We're going to multiply by 1/3. Well, things have flipped. The numerator is now the C, and the denominator is now the F. So I've got to double my octave. So how do I do it? 1 becomes 2, 2 becomes 4, and now I want to go over that number, but just enough to make it a number between 1 and 2. The ratio of the F is a 4:3 ratio. Okay. Now, what is a major third above F? And it's the A. And you'll notice where we have a spine of fifths down here, we also have a spine of fifths above it. Okay. So going east, west, west, east is going to be perfect fifths. Going north, south are going to be major thirds. Okay. F to A. Let's find out the ratio for this one. Well, we know that here we divide by, or we multiply by 1/3, but going up, we multiply by 5.
Dave,
Yeah.
isn't it on the reciprocal, the top number is less?
No,
Oh, okay.
you still want to get
I
that
guess
one.
so, okay.
Yeah. So now we're going to multiply by 1/3, and we're going to go up. We're going to multiply by 5. This becomes 5 to 3. And so this A's ratio is 5 to 3. Number still between 1 and 2, right? We don't have to double anything. We don't have to octave reduce. But what do you notice about the lattice now? There's a problem here. There's an ambiguity. And what's the problem?
Got 2 A's and they're different.
You got 2 A's and they are tuned to different frequencies. They are 2 different A's and they are both related to the C in the center. So which one do I sing? Which one does my choir sing? Well, it depends on the context of the music, because we're going to tune to the music. We're going to tune to the musical context of perfect fifths and major thirds. So if I'm in the key of C and I'm on an F chord, I'm probably going to be tuning this A to that F. But if, on the other hand, I go to a dominant chord like GBD, and then maybe to a 5 of 5 or even a D minor, this A is going to be related through the dominant now. And so I might be performing that A. And the students don't know which one. You don't even really have to know which one. If you're listening carefully and really in tune and trying to really tune up, what you kind of do naturally is you tune to the perfect fifths and the major thirds. It's hardwired in our anatomy, in our biology. It's there. So you can get to those. Now, as a conductor, sometimes you just change your hand shape a little bit. You get a different sound out of the choir, if you've ever experimented with that. I know the conductors have. And so if I can guide my students or just tell them to relax the throat a little bit and they relax, or they change the color of their vowel, they can settle into these other tunings and make it sound in tune. Intuitive singers do it anyway. For us, we're learning the science behind it, is what we're doing, right? Okay, it doesn't make or break you as far as a musician if you don't know this, but it's fascinating to know. It's fascinating to know that my eardrum can hear a 5:3 ratio A, and it can also hear a 27:16 ratio A. And this creates problems when, let's say we're on an F chord in the key of C and we sing an A and we're holding that A, and now my sopranos have to hold this A, and then the notes around it change to maybe a 5/5 chord, D, F sharp A. The A changes. The A will change tuning while you're sounding it. While they're holding that note, it's got to change pitch. It's got to give a few vibrations here or there if it wants to stay in tune. That's amazing. And that's one of the difficulties. Tom said he wants to figure out, how do I deal with that when the barbershoppers are singing and then things change, the context changes around the note, right? That's part of what we're exploring. Okay, so we've got the overtonal dimension, we've got the reciprocal / overtonal dimension. What about the other side? What about when we come down this way? Okay, well, let's start here. What's a major third below C? A flat. When we go to the reciprocal dimension on the up and down, same type of thing. Times 5 is up, times 1/5 is down. So what is the ratio of the A flat? Anybody?
8/5.
Tom says 8/5. We go down once, which is 1/5. So we put our 5 here. We start with a 1 here, becomes 2, becomes 4, becomes 8. And the ratio of the minor sixth is going to be 8/5. Very good. We're going to experiment with that in a minute. Okay, let's go to the major third below the dominant. E flat. We got a major third here. We've got a perfect fifth here. Sometimes easier to start with perfect fifths on your way. So let's go times 3 times 1/5, 3/5. Double the 3, it becomes 6. Doesn't have to be a 2 or a 1 to 2 to 4. It can be any number. And in this case, it happens to be a 3, right? So we double the 3, we get 6/5. So the ratio of the minor third is 6/5. It's overtonal and reciprocal.
Major.
Minor third from C to E flat.
Oh,
Yeah. Okay, let's get one more. Let's go this way. This is going to be our B flat. Getting more complicated. What is our ratio of B flat?
9/5.
3 times 3 is 9, times 1/5, 9/5. No octave reduction necessary. Very good, Tom has it. Well, we've almost got all 12 notes of the major scale as we hear them from a single tonic. So let's get the last one. What is the last one? Could it be a C sharp? No, in the key of C, we never actually hear a C sharp. Why? Because it is too far away from C for us to really hear it as a C sharp. We would have to modulate. We'd have to go to the relative minor and then turn that into major. If we wanted to hear that C sharp, we'd go from C to A minor and then turn A minor to A major, which is not difficult, but now we've modulated. And C is no longer the creator of that tuning universe. Now A is the center of that tuning universe. So in the key of C, you don't really hear a C sharp. In equal temperament, sure you do. You hear it all the time because all the notes are equalized. But in the world of overtones, you don't. Where would C sharp be? C sharp would be way up here. Is that still showing? Oh, no, it'd be way over here, above the A, right? Well, F sharp is complicated enough. We don't need to figure out the ratio of C sharp to know that it's going to be that much more complicated. The ear doesn't like that. The ear likes the low prime numbers. So the ear is going to hear something much closer, which is a D flat. So the next time someone tells you that a C sharp and a D flat are the same pitch, you can tell them, no, they're not. Not from the vantage point of a tonic. F sharp, G flat, no, they're not the same pitch. Different. Okay, so you'll notice that you don't see any D sharps on here. You see E flat. D sharp, who knows where. You don't see any G sharps on here. You don't really mess with a tonic dominant drone anyway. In Indian music, you stick with that tonic dominant drone. I like what that blog sent that Tom sent the blog, a guy talking about tuning. And he said, you can have overtonal tuning, or you can play in all keys with equal temperament, but you can't have both. You cannot have both. And so people in the Western world chose to play in every key. People in the East, like in India, chose to stay in one place and use all the overtonal beautiful tunings of many different notes, sometimes as many as 32 notes for an octave, right? Where we only have 12. So it's two different approaches to music. Indian music gets very deep into the melody of everything, whereas Western music developed its side of harmony and harmonic possibilities, chords, and all that. All right, so where are we? We're finding out the ratio of D flat. 1/3 times 1/5 is something over 15. 1 becomes 2, becomes 4, becomes 8, becomes 16. The ratio of D flat, the minor second, from C is 16 to 15. Once now, okay, we got 12 notes and an extra A to boot, but these are the notes of the chromatic scale in the way that your ear would hear them from the vantage point of C. You don't hear C sharps, you don't hear G sharps, you don't hear other notes. You hear these ones. Okay. Take this little guy out of here. And let's just add a couple of more just for good measure. What note do we have here? B flat. What is the ratio of B flat through the subdominant?
$16.9.
16/9. We have a 9 to 5 B flat that's a little easier to hear over on that side, on the dominant side, on the overtonal side. But on the subdominant reciprocal side, we've got a 16 to 9, which is still not very far away from C. And if we go through subdominant, we can hear that B flat, and we can tune that B flat, and we can sing that B flat. Let's get the third above that. All right, what's the ratio of this D?
10 to 9.
10 to 9 D. This D is not very complicated compared to a 9/8. It's a little more complicated, it's a little farther away, but it's very easy to hear. So we can sometimes be related to this D through the subdominant side. Say I played an F chord, F-A-C, and now I'm going to switch to a D-F-A. It's related to this chord. It's got two notes in common. We can easily hear the 10 to 9 D. It's lower in pitch. We go this way, Pythagorean, up to the 9/8, associated with the dominant chord. 9 to 8, very easy to hear too. So these two Ds, so these present a lot of the tuning problems that our choirs have when they can't quite stay in tune. Sometimes it might be a matter of singing the wrong D or singing the wrong A. And we got to guide them through that. Unless they have perfect pitch and they stay in tune anyway. When I had a bass and a tenor who were in tune all the time, my choir stayed in tune all the time. And it was cool, made my job a lot easier. Okay. I recommend writing this much out. Maybe even get rid of the extra A, B flat, D if you want to, and just practice writing down these ratios so you get familiar with it if you really want to know how that works, right? Just write it out several times. Maybe as you practiced your circle of fifths back in college, like I did, with just writing it out 1,000 times till it stuck in my brain. It's a good idea to write these ratios out so that you can feel like you got a command of that. Okay, let's go ahead and take out some of this stuff. So I'm going to take out all the ratios. Where do we go from here? Where you go next is experiencing those different ratios and singing them. How do you do that? Well, you get into the book and you look in these first 8 chapters, which I've told you you should maybe read through. And if you read through those, don't just read through them. You got to go sit down at the piano. You got to go sit with an instrument and you've got to explore and experiment yourself. Because the piano's out of tune, you have to be careful how you use it. Because if you're playing these ratios and thinking you're hearing the ratios, you're probably not hearing the ratios because the piano's out of tune, right? The piano is tuned to equal temperament. So you have to get some other kind of instrument. He suggests the easiest way to do it is to get a guitar and tune notes to certain drones so that you can sing against those drones. Now the perfect fifths on the piano are pretty good. We said a perfect fifth is 700 cents. 7 half steps, 100 cents each, 700 cents for a perfect fifth. But that the overtonal note is actually 702 cents. So the piano fifths are pretty good. To hear 2 cents out of 700 is probably not in our easy listening. So I wouldn't worry about it too much. If you're going to play perfect fifths on the piano, you can do that. Once you start compounding things, it makes it more difficult. So it might be nice to have an instrument. I actually bought a tambura from India when I first started studying this because a tambura has only 3 notes. Actually, it has 2 notes. It has C and it has G. And it has 2 C's and 2 unison G's, an octave C, a G, and a higher C. And this is the backbone of Indian music. Well, where did Alauddin get a lot of this stuff? He got a lot of this stuff by studying with his teacher, Pandit Pranath, who taught him raga for 20 years. So he learned a lot about these kinds of tunings through Pranath. And they used to run workshops in India every year, and they would buy all these tamburas and they'd have students go and pay to go study in India for 2 weeks or whatever. And then when they were done, they sold off the tamburas. And so I contacted the guy who was doing the class, was a friend of Alauddin's, and I was able to buy my tambura. It's got long strings. The male tambura, it's about 4.5 feet tall, and it's got long strings, and all it does is play drones. And if you can play a C and G drone and induce harmonics off of those strings, you can find some of these pure tunings. And the strings are not as tightly wound as, say, the piano strings, which start to go a little out of tune because they're so under such tremendous tension. But a guitar works, a keyboard works that has that has the ability to play in just tunings if you've got something like that. But if all else fails, take the piano and just go sing these things and do the best you can with a piano. It's well worth the time. And it's necessary for you to experience these resonances if you really want to understand them. Okay, Art has a video for us. Let's move to that. I'm going to make you co-host. All right, sir, you are co-host. I know I wouldn't play. It played for me earlier.
Oh, it did.
Yeah.
Maybe just refresh the.
Son of a gun. I refreshed.
Hello, guys.
And it's playing.
Just want
Okay.
to,
There you go.
All right, so Art doesn't need to share. Now I'm going to share. It now works.
Crash on you.
Oh, did it?
I'm off the Zoom.
Okay, so what Art has done, Tom, you want to come watch this over here. What Art has done is he was able to slow down the vibrations of C to where it's like 1 or 2, and you hear them as taps instead of as pitch, right? So here we go.
Show you a little demo of what I was saying in the class, that if you speed up rhythm enough, we will recognize it as pitch. Rhythm is just a slowed down version of pitch. And here it goes. So I just slowed down a sawtooth wave, very, very slow, and it sounds like this.
There's a 1-to-1 ratio with itself.
Okay, so much like a metronome. But if I go an octave above, which means twice as fast, that's twice as fast. Double that. Double that. Double that. Double that. Double that. Now it sounds like an E. Slowing down again, half that. Half that. Half that. Half that. Half that. And back to the original. Okay?
Now that's the most musically geeky thing I can offer you guys. I think that is just amazing. It blows my mind every time I watch this video. There's proof positive of what's going on in our eardrum. Our eardrum is going so fast that it's hearing these taps as pitch when they go fast enough. Okay, Art's going to move us into the perfect fifth and the major third, which are a 3-to-2 ratio and a 5-to-4 ratio.
So that's very interesting. Now, we'll go with, well, we just did 2-to-1 partial, right? That's the octave. 2-to-1. That's twice as fast. That's 1-to-1. Okay. And then the third partial, which is the fifth. Let's see if I could do this. So you recognize that? Wait a minute, let me get it better. I need to sync it up.
Hard to hit them at exactly the same time.
Yeah, hold on.
Looking for the hemiola.
There you go.
No.
And it's still not mixed. There it
better.
is. That's our fifth, and so it's
it's a
3
little
to
off.
2.
Yeah, right, it's good.
And if we just increase the speed of that twice as fast, okay, double that, double that, double that, double that, double that. Now it's starting to sound like a fifth. Double that. Oops. Now you'd be good. Okay. Let's slow it back down.
Okay.
So we're back at our original. Okay, this is an example of.
And so as he plays with this, he starts to realize, okay, it may start sounding like a perfect fifth, or it starts sounding like a 3-to-2 ratio, but then if it's just a little bit off, the cycles don't quite line up exactly, and that's what you were hearing. But it's still a perfect fifth. It's maybe just not the perfectly overtonally tuned
Right.
3-to-2 ratio if you don't hit it right on. But once you speed them up so fast, you hear a fifth anyway. It may be just a little out of tune.
Well, and it's 2 cents off the start, right? So that 2 cents is gonna keep adding up.
Right,
Yeah.
exactly, because yeah, you have a good point, because this is set into equal temperament. thing.
Oh.
I should have switched it into just intonation, because this keyboard can do that.
Really?
Yeah.
That might be a second video. Okay. All right. So now we'll move to the major third.
Of a third.
E to G sharp.
May.
Seems to
It's
be
just a little
better,
bit out of
but
sync,
you
but
have to
it's
do that.
very similar to our exercise. Double that. 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 Now that sounded like a third to me. Amazing, isn't it? If you speed it enough. Let me go back down.
That's a very good question.
Very
And
good
is it different for each person?
Yes, very subjective, I guess.
And we're back to our little blips.
Here you go.
Amazing.
Dun, ka, dum.
Example of physics for you. Hope you find that interesting.
Absolutely. Thank you, Art. Yeah, that was
Thank
really,
you.
really
That was
cool.
Really great.
That's a great
Thank you.
demonstration, and I'm going to put this on Montoya's Great Listening. So I'm sorry, on Montoya's Great Music Theory Practice, so you guys can see it all you want and use it if you want to show other people how that works. Okay. All right. So part of the experiencing things, that's the work that you really kind of have to do yourself if you want to learn this subject and really understand what you're hearing and understand how these things work. you got to go sit down with it. You got to go take the time and see how that feels. Let's try one example or experiment of how things might feel. For example, now our ear gets the ratios of the major third, I'm sorry, of the perfect fifth pretty easily. It doesn't get the ratios of the major third as easily. We don't hear major thirds the way we hear perfect fifths. When harmony moves by perfect fifths, we hear that. We hear it real easy by perfect fifths, right? But when we start moving by thirds, why do augmented chords sound so weird to us? Because it's two major thirds stacked, right? It takes our ear longer to process that as opposed to perfect fifths. And so learning to hear the reciprocal side and to hear the major thirds, it's more of a challenge, it takes more time. Let's try one. Let's try and get from the A flat. Let's see, if I played a C like this note, somebody sing me an A flat down below that C. Good, Tom's got it. And the question is, so the exercise he takes you through the book is to hear it as three blind mice. Three blind mice, which is just off the perfect fifth by a minor second, right? Does it sound like Lord of the Rings? Okay, so can you nail it off of every pitch? Shall we all try it? Here we go. Tom, that was your first one. You got your first one. Here's your next one. He got it right on. Took him a little while to get to it, not maybe as quick as hearing a perfect fifth above, right? Okay, and here's another one for you. Is that you? Were you humming?
Yeah,
Oh, that was for him, Art.
Oh, sorry.
Don't steal his
Sorry,
notes.
sorry.
Okay, all right, here's another one. Good, Tom's nailing them right on. For some people, this is strangely elusive. It's difficult to find that major third. You start singing minor thirds or you start singing different patterns, right? But it's always three mice, three blind mice, three mice. And when students do this, sometimes they'll move the half step and they'll hear it someplace else and they don't quite hear that major third below, right? Okay, Art, your turn. Yeah, there it is. Okay, it tricked you at first.
Yeah.
Next. And very good. Okay. And if there's a slight little hesitancy, that's okay. But it shows you that the thirds are not quite as, we're not as quick to find them. It takes a little bit more effort. Let's go to Aaron. You want to try this, Aaron? Here's a note. Sing a major third below. You were somewhere between there and there. Yeah. D3 blind mice.
All the way down.
What we're doing is we're tuning major thirds upside down, and that's tricky, right? Here's another one. Okay, very good. Next one. How about up here?
Sorry.
Very good. Okay. Yeah. If you can hear the note as the third and you're going to sing the tonic, then that makes sense. Vanessa, you want to try that? Here's a note. Let me change the octave for you. Right on. Next.
That one confuses me so much.
Really?
Yeah.
I wonder why.
I get.
Sing Three Blind Mice.
I can't hear it.
You got the three and you got the blind. I heard it in there. Sing them again.
Again.
So that's a half step. You're making the last one in the half step where you want to make it to a whole step. That's a perfect fifth. So it's difficult to hear major thirds. It's difficult to hear major thirds going up, but turn them into reciprocals, that's even trickier. Three blind mice. And you hear the first note as the third of the scale, right? Okay, very good. Let's move on to Marcelo. Want to try that, Marcelo? Here's a note for you. That's it. Very good. Okay, next one. And last one. Yeah, that's good. Okay. See how it takes us time to think about it? Okay, well, wait a minute. Am I right on? That's
I did
something
better than I thought I would.
that was good. So sit down at a piano, play any note, and see if you can hear mice off of three, right? If you can hear that off of that note, then you're starting to hear those reciprocal major thirds.
One factor too, doing those kind of exercises one right after the other, you get used to that one, the first example, for example,
Mm-hmm.
and then the second one, because your ears are kind of adjusted to the first exercise, it takes some time to reorient yourself.
Correct. Your ears are kind of stuck in a key, even after three notes. They feel like they're in that key, and now you're hearing another note. And so I'm purposefully putting them in places that might trip you up because that's my job, right? To stretch your ear. So, so sometimes I'm playing two major thirds in a row, right? If I sing a third, da-dee, da-dee, to get the next, that's an augmented triad. And that's really strange. We don't use those as much, do we? I watched a video the other day. It was pop songs that use augmented triads. And they were going through a lot of Beatles songs that used augmented triads. It was like a 20-minute video. And some of the times I was saying, okay, right on, I understand that. And other times I'm saying, you're explaining it wrong. You're spelling the notes wrong. What's wrong with you? And he was simplifying the things. For example, it was a spell for me an E augmented triad. I hear two E G sharp B sharps over here, right? And he's saying E G sharp C. It's not C. It's not. It has to be a B sharp because as we're learning through the lattice studies, B sharp and C are not the same thing. Dag nabbit. And so the guy was explaining it wrong. I'm like, why is he doing that? So anyway, he was a young guy. Didn't know what he was talking about, maybe. But some of the things were good. So I got some good out of that. Go look at that YouTube video if you want pop songs that use augmented triads. It's got some good stuff in it. Okay, so here's a beautiful one that I can just touch on a little bit. I was remembering it this morning. I was listening to chapter 9. Chapter 9 is a good one that kind of ties everything together. The sound of the, let's go find this. If you got your books, go to, did you lose your book, Tom?
It's at home.
Oh, no. Okay. Well, I don't necessarily want to go there. The idea of hearing the reciprocal minor third of E flat when the C and G drone are creating E natural creates a very odd sound. And I remember Andrew and I sat here and figured that out once, and we listened to that and we were like, whoa, it's this really amazing thing. I recommend that when you get to chapter 9, hopefully this week you go read chapter 9. Um, and and see that part where you're singing an E flat, you're in the key of C, and the C is automatically generating an E in the overtone series. So you kind of hear both at the same time if you're listening really carefully, and you can hear those overtones, and it's weird. It's a weird resonance, but it's real exciting when you fall onto that. Okay, let's go back to this guy up here. We took out all the ratios. I recommend you go practice writing them so they become much more familiar to you. What I love about the lattice in theory studies is that I can get my students to start to see shapes here that that help you to learn your theory. So what do we see? We see that a triangle is the shape of a major triad. And the root is here. We learn that an upside down triangle is a minor triad. This would have helped in beginning theory. And the root is here.
No. It's on the bottom.
ACE.
Oh, sorry, the root of the chord, sorry.
Yeah, the root of the chord.
Yes.
So an A minor triad would be ACE, whereas a major triad would be CEG, right?
Right.
What else can we see on here? What is this shape?
Oh.
There it is. That's an augmented triad with the root on the bottom. We go up 2 major thirds. We've got an augmented triad, right? How do you spell a D flat augmented triad? D flat F A. There it is. How do you spell an A flat augmented triad? A flat C E. It's very easy to find. I like that. What is this shape? There's our diminished. So we can start to see shapes, and we can start to see how those notes interact with each other and such. We can also see scales. So if I know I've got my C, D, E, F, G, A, B, well, let's see how that works. Okay, look at these 3 triangles. Let me take off this one for a moment. I got 3 major triads. I got a 1 chord, I got a 5 chord, and I've got a 4 chord. How much more proof do we need that subdominant is called subdominant? Because it's below, it's the dominant below the tonic, right? Just as the dominant is on the other side. You guys can see on my wall up there, I put up chords in this exact order so that you can see I got the 1 in the center, the 5 over there, and the 4 over here. Kind of teach chord progression. Now, there are my 3 major triads of the major key. Should I change color? Yeah, why don't I? All right, check this one out. Then here is my 6 chord related by 2 notes to the tonic triad. Here's my 6, A minor. Here's my 3, less used. And let's not go that way. Let's go this way. Because it's usually related this way. And there's my 2 chord. All right, so I've got all my chords of a major scale. Now, when I first learned this subject, and I got one of these lattices that was that our teacher had printed out all of, several spines long, like 12 notes long. It was this long sheet of paper. What I did is I made transparency paper, and I drew these shapes on the transparency paper. And I saw that if I changed my C universe to a G universe, all of a sudden everything moved over, and I could see where everything was for the key of G, or the key of F, or the key of B flat, or wherever I wanted to go. It was a fascinating way to be able to look at the relationships of all the notes and how they're the same in every key. The strange thing is now I can see the shape of a dominant seventh, C, E, G, B flat. But when we tune it, uh-oh, Vanessa got kicked out. But when we tune it, we don't actually hear this one. We hear the E flat that is somewhere else. Let's just look at GBD. GBD, we don't hear this F, it's getting too far away. We hear GBD F, and that's a weird shape, but it works. So let's look at the shape of a dominant seventh. You could say a dominant seventh. You could say it's this, but it's actually this. It's actually this. The way our ear tunes it, it's this.
Okay.
This is your triad, but you're hearing the seventh from subdominant land. So it's got this mixture of energy. It's got this mixture of subdominant energy and dominant energy. Okay, let's look at the south side. If we wanted to look at the triads for, let's see, C minor. Here's C, E flat, G. There's the one chord. Here's our, oops. Here's our small five. Big five is there already, which we use when we're in harmonic minor, right? And then here's my small four chord.
Interesting.
And then you got the, let's see, we've got the major triads too. So in the key of C, here would be my six, my big six. Here would be my big three. And you could, if there was an F over here, you'd see that here was my big seven, which we use sometimes. It's much farther away from C, but we use the diminished triad BDF. So you can kind of see how everything swirls around. If you want to get into other shapes, you could say, what would be? What's that?
Major seventh.
It's a major seventh. More correctly, we should probably make it like this. CE, if you wanted to call it CEGB, right? That would be the spelling of it. C to E, G to B, and that would be a major seven chord. And so you can see so much in this lattice, and it's just beautiful. Well, what Aladdin finally does is, let's go to page 164 in your book. And Tom, you can come check this out over here.
164.
164 in the book. That's chapter 22. Now, this lattice is nothing new. People have been talking about this and using it for a long time. Aladdin's part that makes it different is the staff orientation, using actual treble clefs and bass clefs in there. And then getting rid of all the staff orientation and leaving you with a chord lattice. Okay, so if you see on page 164, you've got an extended lattice that goes further than we have gone on the board. Imagine those ratios on the outskirts of town on this lattice, right? They get pretty complicated. And then after putting in all the chords, he takes away the lattice itself and he leaves a chord lattice behind take a look at page 165 and you'll see the chord lattice. A student of mine is trying to learn to be a better songwriter. And when I showed her the lattice, she was like, oh my gosh, because she was able to find which chords went with other chords very easily. You just do what Aladdin calls matchstick harmony. I start on C, I go up to G, I go up to D, I go back to G, maybe down to F, and back to C. If you're gonna jump 2/5, fill in the fifth you missed. So if I go from C to G, or if I jump from C to D, then come back down and fill it in with a G before returning back to C, right? If I jump 2 down to B flat, then go to F to fill it in on my way back to C. And you start making all these beautiful chord progressions. And you start to write music based on that. It's a very easy way to understand how to write chord progressions that make sense, because your ear gets a chance to move in and out of each chord that is related to it. Now, some of the great part about music is when you take unexpected leaps, or when you start off in a westerly direction on the lattice and you end up coming back home through the west or the east side. Or if you start off heading off east and you come back west. For example, let's go from C, let's travel due east to G to D minor. And now I'm going to go from D minor, which is over by G. I'm going to go to F. Well, I've just flipped sides of the lattice. All of a sudden I'm on the west side, and then I come back to C. So C, G, D minor, F to C. Guess what's happening on that D minor? Tuning is changing in the very act of going from D minor connected to G to D minor connected with F. And our singers have to change their tuning if that's the context of the music. This is all about context and what the notes are around it, right? And so when you do that, sometimes you're actually changing your tuning while you're holding notes. And maybe it's only one person or one section in the choir that has to change their tuning. If I go to C to G to D minor, back to G, back to C, unambiguous. No one had to do any tuning differences. They just followed their ear, right? But if I go C to F to D minor to F to C, same thing, no tuning discrepancies. But if I go east and then come in through the west, I've got to have some tuning changes. All right.
So that really made me think of a question. So it means if you're sight reading the piece and really don't know what's coming next, you're at a disadvantage because you might be out of tune.
Yeah.
But if you've studied the piece in advance, then you have the advantage of staying in tune even if you flip
Correct.
poles, right?
Correct. And flipping poles is what we're talking about.
Right.
That's a good way to say it. So this chord lattice is awesome, and I encourage you guys to go and sit there and play through them and follow some things. If you go to, now this gets ahead of where we're at, but if you go into the book and you look at, let's see, where does he talk about this? There's a chapter called there's a section called Matchstick Harmony. And I am not seeing it. I'll find it and send it to you later. It's in here somewhere. There's another section called Pathfinder and Homebody. referring to how a note goes traveling away from its original home and then has to find its way back. And sometimes it thinks it's going one direction, and all of a sudden it's coming from a different direction. Matchstick. Where's the matchstick harmony, Aladdin? Oh, there we go. Okay, 158. Sorry about that. 158. This is great piano exercise for you to kind of just feel where chords are that are unambiguous, don't have any tuning problems with them. They just lay flat. So if I'm looking at page 158, I'm seeing a chord progression down below that follows that lattice, that chord lattice. So here's example 21.6. Wow, that's really beautiful. And it went someplace. It didn't just stay in the chords of the key of C. It did a little chromatic harmony move, but it's staying connected by matchsticks laid out across the lattice. And very easy to play too, because of the way it's been written with the inversions. So here's another one, example 21.7. Very nice. This is the basis for musical composition. You can take that and now you can say, okay, I like this chord progression. Now I'm going to improvise on it a little bit. Right, and so you start to flesh it out and you start to create a little composition exercises out of it. We can do some of that if you want to move into that, if that interests you. But go read this section on matchstick harmony. It's a really good place to move if you want to know more about the lattice. Okay, Art.
So the matchstick harmony example, does that mean that you don't really have to make any tuning adjustments?
Right.
Like the ratios, for example, there's two different kinds of A's.
Right, you're not going to have to make any tuning adjustments because it's following matchsticks connected to each other and then comes back or takes a different route, but it never leaves one direction and come back the other direction.
Okay.
When we do that, those are called commas. And next week, we're going to talk about the commas. There's 4 main commas that we have, talking about 2 different kinds of Ds and 2 different kinds of As. Those are what we call commas. It's that little difference in pitch between one and the other. And we've already sung through a comma. We sang through a comma on our very first day when we sang the 2 different kinds of A's. And so we'll talk about this. And you can sense that more when you've spent some time with the simplest of ratios based on C and how those notes relate to C.
Is that the same thing if you say diatonic, or is it different?
Diatonic, the way I like to explain it is that diatonic are all the notes of the given scale that you're playing in. Chromatic goes outside those given notes. If my notes are C, D, E, F, G, A, B, C, and I add an F sharp, that F sharp came from somewhere else. Unless I'm playing, okay, so that F sharp came from somewhere else, therefore it's a chromatic note, right?
Right.
Okay, but if I choose to play in the key of C Lydian, that's a diatonic note to the key, to the Lydian mode, right? And that F sharp is not chromatic.
Is that the same though, what you say on those previous 2 examples? Can I call this diatonic? Like the first example, for example?
I think you're wandering far away from C. So that first example that has an F sharp in it,
Right.
I think to my ear it sounds chromatic because I was in the key of C.
Right.
But I wandered away.
Right.
And
So
I
it's
went
not
to-
synonymous, but it's almost the same.
Yeah,
Not almost. Yeah. Okay.
that's a good question. Chrome, somewhere along the line in the development of the word referred to color. Right? Have you heard that in science, right? Okay, so if Chrome is color, like the little Chrome symbol for your Google browser, right? Chrome's different colors. So when we add color to the scale that we've chosen, we're adding chromatic notes. Yeah. All right, ladies and gentlemen, any more questions? We're going to talk a little bit about melodic sequences here real quick. I promised Art I would show him some, but you're all welcome to keep listening, or you're all welcome to go and explore ratios with your piano keyboard or your detuned guitar so that you can start to experience how these feel. He guides you through each one of these, how to find each note and how to find each ratio. So read carefully, go back and look at those chapters again. How do I find an A flat from a C on a guitar? How do I find an F, which is a reciprocal note? How do I really feel what that feels like so that I can have my own sense of it instead of trusting that I or Aladdin or someone else is telling you that that's what it is? Don't trust us, trust your own ear. All right, everybody, you have a great week. We'll see you on Monday. So there's not a lot of days between now and our next lesson. We'll see you on Monday.